Welcome to Walk About the Galaxy, the Back in the Studio astronomy podcast, where the science is universal, the opinions are personal, and we've got new digs.
New digs?
Yeah, back in the studio, but in a different
It's a
studio.
new studio.
A new studio.
It's worth mentioning why it's a new studio.
Studio.
Because
Is it?
Oh yeah. As Addie and I are well aware, the new studio, it's even bigger than the old studio, which was pretty big to start with.
Enormous.
It's huge.
By studio standards.
By state university
By
faculty
state, yeah.
office standards.
Because
By
Josh
pretty
is
much
now,
every other standard, it's not very good.
Josh is now the chair of the Department of Physics here at the University of Central
What?
Florida. He's now Addie and my
Addie's and
boss.
Yeah.
More than you already were.
More than he already was. So now, everything he says in the podcast will be correct. 100%. We will not fight in any way, shape, or form.
A stranger situation could not have forecast or something arisen.
Probably could have.
Yeah. We are Strange Charm atop the Astrocortex, also known as Josh Caldwell,
Addie Dove.
And Jim Cooney.
coming to you from the new Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. Actually, I think that's the entire list.
Yeah, it's not just including.
It's not including. It is including those, but but that's it.
It's just the set that only
That's
includes
it.
those.
The set.
Including all of these.
Which brackets do you use for that?
I don't know.
Yeah,
Square
that's
brackets,
the
I think.
entire set. We are also on something called the World Wide Web at walkaboutthegalaxy.com, which is woefully out of date, but soon to be amazingly up to date.
Excellent.
Ooh.
Maybe by the time you hear this podcast.
Maybe, but probably not. Where you can see how to order a Walkabout shirt and support STEM education at the same time. Our stumpers today are romantic.
Oh.
And this is
Eddie and I are suckers for romance.
Are you? What superhero or any fictional character, but let's keep it genre. Let's keep it sci-fi, fantasy superhero. Okay. Walkabout genre. What superhero or fictional character would you most like to have a date with?
Wait, is it superhero or like
It could
fictional
be.
character?
It could be
Like, is it
Jean-Luc
Star
Picard.
Wars, okay, Star Trek.
It could be Han Solo. It could be Superman. It could be the Hulk.
It's just a date.
It's an open-ended date.
Okay.
You know,
Yeah,
it's
you're single.
definitely
You're single, and this is a date.
You're single. The superhero or fictional character is also single
Sure.
and interested. It's not. It's not like a. It's not like one of these charity auction things, you know,
Oh, yeah.
where you're
Yes.
just like going to go out to a nice restaurant and
Yeah.
you know nothing's going to happen.
Yeah.
Something
Okay.
might happen, but it's not guaranteed to happen because that would be illegal, right?
All right, Jim, go first.
Oh,
She
I guess
has
you
it.
can pass. You
Um,
can pass.
I'm
If you go first, you have the right to pass. That's a stumper.
It is a stumper because there's so many to choose
many
from,
options.
Yeah.
but I think that my immediate reaction is, and I hope that most of you guys know who this is Kaylee from
Oh,
Firefly.
I do know her.
Oh,
Yeah.
I love her so much.
I think I remember her saying that it had been a while since there had been things twixt her nethers.
Yeah.
If I recall the line.
Yeah.
correctly.
It wouldn't be so long if I was there.
adorable.
And I believe that is quite likely the only line that I could recite to you from all of Firefly. I don't know if that's in the show or Serenity.
That's in the show.
I think so.
Yeah, but it was such an odd turn of phrase that it stuck with me.
Yeah.
all
I'm
these
sure that's
years.
the only reason.
Well, she's awesome. She's
Well.
smart and I don't know. I tend
Adorable.
toward the kind of the cute girl next door kind of look, and she's got that in spades. So.
Has Kate Winslet played any superheroes or science fiction? She played an evil science fiction person in that series with that other person, but
Good
I don't
reference.
know. Yeah.
I
I don't think so either. So I'm stumped.
So
But
you're stumped
that's
then.
why I posed the stumper
I see.
instead of the
It's
answer.
such a huge universe.
Well, you gotta pick one.
Jim went for it.
I was
Keith
trying
went-
to think of like if it's a single date and you want to be able to like do something really cool, right? You want it to be somebody who can like take you somewhere, like whisk you somewhere.
Okay, so you want to like
She's gonna whisk me somewhere.
Yeah.
You want to go for a ride, piggybacking on Iron Man or Superman for a flight
or like
around the
somebody with a
planet.
spaceship.
Uh-huh.
I'm stumped.
Okay.
I'll
You're stumped.
I'll
We'll come
shout
back
out
to you
the
at the
name
end
at
of
the
the
end
show.
of the podcast.
All right, there we go.
Yeah, I will.
There you go. Today we'll talk about the Earth's aurora and
Yay.
discover that I didn't know what I've been talking about all this time.
And Jim's the one who brought it up this time, not me.
Unidentified aerial phenomena and going back to Venus. But first, this episode of Walk About the Galaxy is brought to you by Herbig Haro Objects.
Oh.
Stumped about what birthday present to get that special someone who seems to have everything? Or maybe they're just so picky and peculiar that anything you get might just get tossed in the trash or regifted? For all your difficult to shop for friends and family, try a Herbig Haro object. Created in the 1940s by George Herbig and Guillermo Haro, Herbig Haro objects come in a variety of colors, shapes, and sizes. Every HH object comes with a guaranteed luminescence of 10,000 years, but will likely last much longer, making them a great family heirloom. Known side effects of HH objects include star formation, high velocity jets of ionized gas, and emission lights in the visible infrared. HH objects are not suitable for children under the age of 3. For a new start, whether for a gift or a gift to yourself, try a luminous Herbig Haro object. Herbig Haro objects, once you pop, you can't stop.
I'm intrigued that you went with 3 as the cutoff age for that.
Oh.
It seemed rather dangerous.
You think, what, 5?
Like 10, 12? I don't know.
It's in billion years.
You know, this is, I don't write these regulations.
No,
so
I
I'm not actually saying that they would be safe for a 5-year-old.
Right.
5 billion year old.
Just that they've been approved.
Okay.
They have gone, you know, the regulatory agencies, whoever they are, have decided that Legos and Herbig Haro objects are safe for children 3 and over.
I
Okay.
don't think
I agree that they
Legos
would have a hard time.
Legos are 5.
Legos are
I
5?
think so.
They're not gonna.
Maybe.
A
'Cause
little kid is not gonna
Too close for
swallow
little kids.
one of these objects.
It's true.
No,
so
it might
that's
be
okay.
swallowed by one. No.
Once you pop, you can't stop.
Pringles?
Pringles.
Yeah. Herbig Haro objects are these sort of visible phenomena that are produced, and there's actually, amazingly, a movie of one evolving. Like, it's rare that you see,
What kind
see
of movie? Like a time lapse series?
yeah,
of
time
photos?
lapse of like 10 or 12 years or something
Oh,
like
cool.
that. And this is some jet of ionized particles coming from a newly formed star, runs into gas and dust nearby and causes it to glow nicely.
And I have to say, the term was created in the 1940s or whatever. The objects existed probably before that.
Well, you'll have to take that up
I'll
with
take that up with the
the
sponsor.
company. Yeah. So they cause these beautiful glowing things, and as the jet goes and pushes the gas and dust, and there's a movie where you can actually see over the course of decades, like
Yeah,
kind of cool that you don't usually see astrophysical stuff
actually evolving
change
like
before
that.
your human lifetime
Right.
visibly,
That's why I like planetary stuff.
because you can just
Yeah.
stuff happens.
Yeah.
Right.
The smaller the scale, the faster things change.
Yeah. Space news, it should, I guess it come as no surprise to us, but Jeff Bezos had an announcement
He did this morning,
as
we're recording. He announced that he and his brother are going to join the auction winner on the first Blue Origin New Shepard flight. It's not clear if there are also going to be other people or it's just those 3. I assume there will be 3 others because there's room for 6.
There's room for 6.
Maybe they won't.
Yeah.
Aren't there pilots?
No.
It's
It's
autonomous.
all autonomous, but
Yeah.
but even on an all autonomous thing, don't you want a backup pilot? No.
To do what? There's like nothing to do.
Yeah,
You don't actually.
is
You
there
really,
not like
you
a-
probably
Really
really
don't.
don't want a pilot because they might just do something wrong.
because they want to touch something. Because they're like, I gotta
Yeah.
control something, but they don't.
I would feel like anxious if I didn't have like the
Dragon
button
is
that.
primarily
Does this thing have like a
ejected.
self-destruct button.
escape pod?
Just
thing?
self-destruct. That's all. No, it
No,
has
I
it.
mean it has parachutes and stuff, and it can have like an emergency parachute. Because they did early on when they were just doing the testing, they did emergency parachute ejection. I forget what they call it.
Well, they got a solid rocket motor in the center of the capsule that, in emergency, gets you the hell out of town.
Away from
right?
the booster.
Away from the booster. It can do that on the pad or anytime during ascent.
Because somebody,
I want the control for that if I'm on there.
Yeah, well, if I'm on it with you, I don't want the control for it
Yeah,
because
no,
I'm
you're
thinking
gonna-
Jim's gonna hit that button.
yeah.
But if
And I don't want him hitting that button.
I mean, it's a 10-minute flight total, right?
Round trip.
Round trip. And they've flown
15 or so.
Yeah. Yeah. Two of this
you guys are gonna
capsule.
be in trouble when the computers take over.
Yeah, this is one where I'm like, I'm okay with the computer.
maybe.
The one thing where they were thinking, and I don't know if they'll do this when they have passenger flights, but you go up and you have 2 or 3 or 4 minutes, depending how you count it, you know, of time where you can maybe float around and maneuver around the capsule. So you're strapped in, 3 minutes of high G's to get up into space, and then you separate from the booster. Then the first thing you want to do is like unbuckle
Yeah.
and float around, look out your big window. And at some point you got to get back in the seat, because you're coming in, you're going to get 5 or 6 G's at re-entry.
Right.
Yeah.
So that's where you may
Dave got
want.
smooshed.
That's where you may want a Blue Origin flight officer to make sure
Yell
you
at
get
you.
back in your chair
Right.
at the right time.
Feet down, coming out. Feet
Instead
down,
of
coming out.
that's right. Instead of just like, you know.
I assume they'll have like little flashy lights in the cabin.
Yeah, but what if
Yeah.
what if you like pass out or something because of
I think
something?
You won't, and I also think that
somebody didn't strap in and just landed on top of the new roof of the new Walkabout studio. It sounded like.
yeah. I assume you'll like watch out for each other, but it's gonna be one of those things like if there's a child, put your mask on first.
Yeah.
Okay.
Yeah.
I don't know
You're
if
not gonna be able
they'll.
to float too far from your seat. First of all, it's not
Yeah,
that big.
it's not that
capsule.
big, and there's 5 other people in there.
Yeah.
All right.
And I don't know, like, if they'll require that you go through some centrifuge thing to demonstrate that you're totally fine handling it.
Yeah.
And it's going to be informed consent kind of ride.
Right. Sure.
So maybe you'll
And
pass
if you were
out.
on the floor,
It's not going to kill
you'd
you.
still make the landing.
Yeah.
It just wouldn't be very
Yeah,
comfortable.
it's not going to kill you. I
Right.
think the worst case scenario is like you're trying to do handstands or somersaults or something when you hit the atmosphere,
Mhm.
Yeah.
and you could land hard and uncomfortably.
I was talking to Carrie yesterday about zero-G flights, and she did some earlier ones with NASA, and there was apparently one of the flights she did was like a new pilot was training, and he did a bunch of like pretty negative G's, so that's where you like actually
people, like,
sort of get
slammed off
thrown
the
to
ceiling.
Yeah.
Yeah.
But then they like, you drop pretty hard because you come
Yeah.
out of it if
Yeah.
they're trying to correct.
Oh
She
yeah.
was like, almost
They were
everyone
bouncing
was
around.
sick very early in that
Oh
flight.
wow. Yeah. That sounds pretty horrible, actually. Yeah.
Yeah. But it'll be fun. Anyway, so yeah, they're going.
Yeah, another item in space news is a short time ago, just a few hours ago from when we're recording this on June 7th, the Juno spacecraft
Oh yeah.
made a close flyby over the largest moon in the solar system, which is
Ganymede.
correct. Yeah,
That's a big sucker.
it is.
That's bigger than Mercury.
It is. And
Oh,
bigger than our moon,
Bigger
and
than our
bigger than Titan
Bigger than Pluto.
by a skosh.
Yeah, there used to be a debate which one was bigger, but
Yeah.
because Titan's got the
Titan's got the
atmosphere,
big,
so it lies
healthy
a
atmosphere
little.
makes it hard to tell in the early days exactly how big it was.
Right.
So the largest moon in the solar system, Juno, of course, is primarily studying Jupiter's interior, its gravitational magnetic field,
Yeah.
and so it hasn't really been targeting any of these moons for stuff. But
Was it doing a gravity assist, or was it just happen to fly by?
I don't think it.
Or like
I
a
don't
trajectory
know
change
for
at all?
sure
Okay.
whether it needed the flyby to
Yeah.
do anything for its orbit. It's on its 30-something orbit
Yeah.
of Jupiter, about 1,000 kilometers above Ganymede's surface, which
Oh.
is reasonably close, but for flying by an icy satellite is not crazy close.
Yeah.
We used to fly by on Cassini. Some of the Enceladus flybys were within like 50 kilometers of
Ooh.
the surface, which is insanely accurate.
But Enceladus a lot
Precision
smaller than
flying.
Ganymede's. If
Still,
you flew that close to Ganymede, you'd need a significant course correction, right? It would-
you would get a bigger perturbation than flying 1,000 kilometers by it for sure. Yeah.
So have
It would
we
do something
flown
to
closer to Ganymede with other
No.
previous Jupiter
No,
moons?
Galileo didn't.
Voyager. Maybe Galileo got closer.
Galileo may have, but the issue with Galileo, the Galileo orbiter of Jupiter, which was intended to study all these moons, had this big antenna problem.
It does say it's the closest since the Galileo mission,
Yeah.
so probably similar distance.
Yeah. But Galileo had a very restricted downlink was not able to send as much cool stuff.
And we have better instruments now than we did then.
We do,
Sort of.
although Juno's instruments are not geared for this kind of remote sensing. It has some cameras, as you spectrometer, but it, and we're going to get some great data from it, I'm sure.
Yeah.
But it's a single flyby. Anyway, that happened.
Fun.
On Nerd News, there's a couple of things I just wanted to ask, because you saw
we watched,
Stowaway.
So we watched Stowaway this weekend.
Yeah,
Tracy said
on
she was
Netflix.
really
I've never heard of that.
It's a Netflix movie. It's with Anna Kendrick and Toni Collette and some dudes.
Good actors, yeah.
Whose names I can
And it's
also
about
remember.
somebody who, whoops, a rocket took off with an extra person on
Yeah.
board.
Oh,
So that's
I
kind
think
of
I
why
saw
I'm
that.
not watching it.
Yeah, so the starting premise is awful.
Yeah,
That starting premise is awful.
I just think that's the starting premise of Lost in Space. Dr. Smith
It's also-
wasn't supposed to be on board.
Oh yeah. Yeah, it's some parts of the movie are like okay, accuracy kind of okay.
Mhm.
Like, without giving too much away, it's like it's a Mars mission thing, but they have this like station that they go to and then they spin it up so they have like 1G in their
Yeah.
station for travel, which I have a problem with, but it makes it easier to film. Like, why would you want to
Right.
do 1G?
1G is.
Maybe they're gonna like slowly decrease those to get closer to Mars, I don't know.
Yeah.
But
That's the
There's
kind of
some
thing where
other
they could probably
stupid-
say we're doing 0.4G and then really just do things at 1G and you don't even really notice.
or say you're doing
Right,
like
that's-
0.8G or something, so like something that, anyway. But there's some other stuff they do that's stupid. And okay, biggest rant. I think
Okay.
I'm gonna put this on Twitter too.
Okay.
Biggest rant for most space things. Freaking use a tether and
Oh my God.
keep it tethered.
I know.
For the most
What
part,
the
they
hell?
use tethers, but then a couple of times they disconnect, and guess what? It causes a problem.
Yeah.
Like that is a fundamental thing
Yeah.
about NASA is you usually have two things.
Right.
You're always clipped into something.
Yeah.
You're never free. They almost never like
Yeah.
occasionally a tool is floated away because it wasn't tethered properly, or like a screw.
Yeah.
But freaking tether things and hold on to them.
But
Yeah.
but
What was the show that I ranted about
Away
with
or something.
where it was another Mars mission
Yes,
thing
I
where they
watched
just
that
did
one.
so many ridiculous things, including their tethers were 5 feet long, but the latch points were 20 feet apart
Yeah, no, they're not
on
gonna
the ship or
freaking
something
do
like that.
that.
It's like what kind of idiots is NASA supposed to be with this thing? And then they say, well, we'll send our supplies to Mars separately from the people, but not before, so
Yeah.
that
No.
if the supplies don't get there, all the people will die.
Oops. We should have
And
planned
just
that
like,
better.
yeah, just wait a year, make sure those things landed
Yeah.
okay.
Which is exactly what NASA or
Yes.
whichever space agency would do.
Anyway,
Go
sorry.
ahead, Jim. What?
well, I was gonna fight back
Okay.
because
Go
I've
on.
seen put up your dukes. I've seen those famous images of some astronaut out there on the rocket with the rocket pack,
Sure.
untethered.
Sure.
He's in a
Meaning-
spaceship. He's in his own spaceship.
Right.
I'm okay
So-
with use of he here because I think there have not been any women who have used the X.
Yeah.
Right, I was specifically thinking about this one
Yeah,
Yeah,
image
yeah.
of one guy.
make something
Yeah.
McCandless or
Yeah.
something
McCandless.
like
It's a
that.
famous
Yeah.
image of like,
Yes.
Yes.
you
On
can
the
see nothing
mobile
else
maneuvering
except
unit.
And do you know why he's not tethered? Most of the time when they used those, they were tethered.
Right.
He was not because they were testing it for
Of course,
this thing,
of
and they
course.
did it for the photo.
Of course.
And
Yes.
it's
And it's a
a
spaceship.
jetpack.
Don't get me wrong. I would always be tethered. I think it's
Yeah.
crazy not to be tethered. But I don't think the idea of at some point in the near future not using tethers, it's just like the idea of me of not
If
having
you've
control
got-
of the.
If you've got the
escape-
space pack, if you've got the
So they didn't have
No.
jetpacks.
no,
No.
they're just out there in their spacesuits.
They're like doing a spacewalk.
And the
along
whole reason they
station.
don't have a tether is for dramatic effect,
Yeah.
so that when something bad goes, they're going to float off into space.
Okay.
We got to get them.
If they didn't have jetpacks, then that's very stupid.
No,
It
there's
is
no
very
jetpacks.
stupid.
It's just them in their spacesuits, and
And the-
like
and the
they're
thing is-
tethering most of the time, and then there's like a couple things, and you're like, "Oops, we're untethered," and you're like,
Yeah, and it's like at least give them a can of hairspray, you know,
Right.
if you're untethered, so
Yeah.
that you've at least got some chance to do something reasonable
Yeah.
that way. Anyway,
tethers.
Tethers.
but you can't shout that at the end of the show. You have to shout
No, I
your
know.
dream date,
I will.
because otherwise I have a feeling you would have shouted tethers.
I'm gonna shout it forever. What was the other space news thing? There was a couple of launches recently, I think since the last time we were.
There in launches.
One was a cargo resupply.
Cargo resupply, a Sirius XM satellite just went up, some more Starlink satellites, so they're getting up close to 2,000 of those things.
The other thing.
Yeah, it's going nuts.
The other space-esque news is this big government conspiracy.
Oh, unidentified aerial phenomena.
Yeah.
Yes, we said we were talking about that.
Rant.
UAPs,
Rant number 2.
Is that what they're calling them?
Yeah,
Okay.
yeah. So,
Why?
for
They already had a name.
But they're not though.
they're not necessarily flying objects.
Right.
So I do approve of the name change.
Okay.
Yeah.
Okay. That's fair.
Because they could just be clouds
Yeah.
or lens flares even, which is
Right.
not even an aerial
Optical
phenomenon.
phenomenon. Yeah.
And so what is driving me nuts is that all of the stories about the military releasing footage and upcoming report to
Yes.
Congress,
Yes. Of unidentified flying objects or
The things-
unidentified aerial phenomena.
bright lights or things showing up on pilots' cameras and things like that that are unexplained, is that they say, well, we can't say that they are aliens, but we can't rule it out.
Yeah, and it's like, yeah, you probably can though.
Well,
And part of the reason they're saying they can't roll it out is because it's a huge national security issue if they can't identify what these things are.
right.
Right? It's a huge failure of our intelligence agencies.
Right. So there's all sorts of non-alien explanations for these, and many of them are probably simultaneously true for different ones of them.
Yeah.
Right.
But
Right.
this,
Yeah,
you
that's
can't,
that's the main point, is that, like, yes, you can't rule aliens out, but it's ludicrous to jump to aliens
right.
when there are so many other more plausible explanations.
I can't actually prove to you that there's not a Hilton on the far side of Pluto.
Right.
It's true.
Right, but it's
I
a
can't
ludicrous.
rule it out.
Yeah.
But why would anybody think that's the case?
Right.
Yeah.
And, yeah, so.
And I've seen a few stories where some of the pilots are like, we saw these things every week kind of thing.
Right.
It's probably not aliens.
Right. Well, one of the late night hosts was saying, because one person was saying, I saw it every day for 2.5 years. And the person's like, and you never thought to bring a better camera? It's like, tonight I'm going to get a better picture of that thing.
Yeah, right?
Yeah.
Yeah, it just seems, I don't know. And I guess it's good that, like, the government, so it's weird that the government has been sort of secretly studying this. It's not weird, it's not surprising. It's good that they're talking about some of it now, but I think it's mostly just annoying.
Yeah. Shall we talk about actual science stuff?
Yeah,
Sure.
we like to do that sometimes.
So let's start with this sort of space news aspect of the science topics, which is the Venus missions.
Venus missions. Okay, so
Very exciting.
it is very exciting. Why?
Because
Because we haven't been there
We haven't been to
for
Venus in
like
so
40
long.
years.
And by
we've been just like
we mean
fixated
US.
on
Right.
Mars.
Yeah, so we
But
mean
nobody has
US.
been to Venus. I mean,
Yes.
I mean, the Soviets went to Venus. with
Japan
Venera.
has.
Japan
and Europe
currently
both
has
have orbiters.
currently
there.
have orbiters at Venus.
I'm a moron. I forgot those.
You're just a
No, it's just they don't
typical American.
They don't get a lot of coverage.
Yeah,
even
I haven't-
even
I haven't
in the science community, they don't get as much coverage.
Right. Yeah, I don't think I've seen a lot of big results from them or anything like that.
So
I don't know
one of
why.
the challenges is the Atatsuki. We've talked about
Atsuki or something.
Akatsuki. I'm saying that wrong. But the Japanese one. One of the challenges with that one is it missed the first time it tried to go to Venus, and it did like an extra loop or two around the sun, and then like 5 years ago maybe is when it finally re-entered. It actually entered orbit around Venus. And they've got some really cool images. So they're mostly studying the clouds because of the imagers they have on board. They've gotten some really interesting results from that. And there's Venus
Express,
Express,
I believe, is the European mission. Yeah.
and it's also doing atmospheric stuff,
Right.
I think. So
Right.
these are all orbiting and studying the atmosphere.
Venus
And
is famous for its atmosphere.
It is.
Yeah.
It's on all the postcards.
Right.
Um,
Slowly rotating, very high altitude clouds, global coverage, atmosphere, very thick, very
Thick.
hot.
yeah.
Yeah.
Right.
But we haven't sent anything into Venus in a long, long time. So the Russians did
Right.
in many years ago,
In the
Right.
70s.
70s,
Right.
and got some super cool pictures.
Right. They
Because
landed a
very
couple
long.
things on the surface
Right.
with some manner of success. They lasted an hour or two or something
Yeah.
like that. Sort of snapped a few photos that we
Right.
had, and that's about it.
Yeah. It's 900 degrees Fahrenheit.
Yeah, the
on
conditions are
surface.
terrible. Yeah, it's
And
90
high pressure.
times Earth atmospheric pressure,
Yeah.
900
Yeah.
degrees,
Yeah.
It's a little
acidic.
toasty. It's really hard to design things to survive in that condition.
Yeah, 900 Fahrenheit is,
We think it's hot outside right now.
yes.
It's like 90
Yes.
Fahrenheit.
Yeah.
Order of magnitude.
Stuff starts serious melting
I
of
start
things that
melting
you
at
don't
90.
expect to melt
Yeah.
normally. But so
So-
NASA has several different sort of class of missions, and some of them are competed, where people write proposals. You know, people like us can even write proposals for these. Some are missions that they do. That's
Yes.
like, we're sending a rover to Mars. That's a NASA
Flagship
sort of flagship
missions.
style. Then they have New Frontiers, which is like the Pluto mission, and Juno that we were just talking about were New Frontiers. Then slightly smaller than that are the Discovery missions, which is what these are.
Yeah, so just last week, NASA announced, down selected, they had previously said, okay, we're gonna look at a little bit more study of these 4 missions, and one was to Io, one was to Triton, and then 2 were to Venus, and they selected both Venus missions,
Right.
Wow.
which is pretty exciting
yeah.
and surprising.
Yeah.
But they're complementary in a lot of ways, like
Very
they have
much.
very different instrument suites, which we'll talk a little bit about, and so it's nice that they'll both be going. It's not clear, I think they might not go at quite the same time, but that would be really cool.
Yeah, I think they talked about 28 and 30.
Yeah.
And that would be 2 different launch opportunities, or maybe they're like, it'll be one of those 2 for both of them.
Yeah.
I don't know.
It's not clear.
So, well, before we talk a little bit more about their instrument
Sure.
suite, since we've gone on random tangent topics so far, I'll give you the random tangent trivia question to mull over, and then we'll hear about Veritas and Da Vinci Plus,
Okay.
and then the Aurora.
Oh,
Okay.
I thought I was doing the trivia. I'm not doing the trivia.
Why do you have trivia?
Yeah, he said, and before we started.
I asked. I thought
asked
I had
and you
received
said
the
Jimmy
positive.
said
It's
yeah.
fine. I'll save the trivia for
I
now.
had no idea.
Wow.
When did you ask that? Here in this room?
Yeah.
Face to face?
Yeah.
And I responded?
Yeah.
Somebody responded.
Anyway,
It's okay.
we'll do
Your
Jim's
trivia is probably
next
better
time.
than mine.
Doesn't matter.
Hey, we'll do both trivia. Go.
No, save yours for next
Okay,
time.
I'll save it for next time.
Really? No, because mine's terrible.
All right, we'll do
I
my
will do
trivia.
Jim's trivia.
All right, my trivia's not that great either,
We can
but
cut all of that out.
That's right. We
can.
won't ever actually do any of the trivia. We'll just argue
No
about it.
trivia stuff.
This is
Well,
what people
my
are
trivia
throwing
Today
at
is-
is
us.
another special Top Court trivia.
Top Court trivia.
Okay.
It's remotely related to the topic we'll be discussing at the end of the show, which is
My
Aurora.
date.
Aurora.
Yes, Aurora.
not your date. It's not related in any way to your date.
But you don't know that.
Unless you date, you've decided that you're going to go on a date with Magneto. We're going to talk about magnetic fields.
Okay, great.
Um,
Which version of
This is
Magneto's
good
going to be a
because my
weird choice.
trivia
He's a
was
little
not
old
related.
for you, but whatever.
Could be from
Not
the
young
one.
Magneto.
Yeah, not young.
Oh, that's
Magneto.
true, that's
There's
true.
That one,
That's true.
yeah.
I was
he was like
thinking
a better
only of the,
person then too.
Right. Oh yeah, he was hot early on. Okay, I'm into it. So magnetic fields. I was just thinking about magnetic fields and the units that we use for magnetic fields. So of course, you guys know very well what the units that we use for magnetic field are.
Gauss and Tesla.
Right. So there are 2 main units. The standard metric system one is the Tesla,
Mm-hmm.
named of course for Nikola Tesla.
Yeah.
And then the kind of Earth
CGS.
magnetic fieldy one, the CGS one is the Gauss, which is nicely a factor of, or a power of 10 different from the Tesla. So it's 10 to the minus 4 Tesla is 1 Gauss. So 10,000 Gauss in a Tesla.
Mm-hmm. Mm-hmm.
So we all know that. And that's, we use the Gauss because it's close to what the Earth's magnetic field is, a few Gauss, depending on where you are at the surface of the Earth. First, by the way, as a side thing, where on Earth is the magnetic field the strongest generally, roughly?
We're on the surface of the Earth?
Yeah. Yeah, we're going to stay near the surface of the Earth.
Where's the strongest?
Tropic of Capricorn, where?
What?
Is that the answer?
No. It's not
Why
the
did you
answer.
say that?
Why did
It's
you
just
say
like
that?
guiding you towards
Oh, I
some
see.
place.
I would have said
Meaning-
near the Arctic Circle is what I would say.
Near the poles.
Yeah, near the poles.
That's
Okay,
it. Yeah,
okay.
that was it. There wasn't no complicated answer there.
Okay.
It's not the Tropic of Cancer.
It's very stressing.
I'm sorry.
Stressing me out.
Yeah. Trivia. Trivia is stressful, Josh.
Trivia is stressful. I know. Okay. So Earth 1 Gauss, 2 Gauss, 3 Gauss, something like that, depending on where you are.
Okay.
So this is a multi-part thing where you have to tell me what the magnetic fields are in various places. Basically, you're gonna have 3 things. First, you could tell me what a typical magnetic field strength is, and we'll do this in Tesla.
Okay.
In the interstellar medium. out in the galaxy somewhere. Not in intergalactic space, but in interstellar space.
Okay.
2, you'll tell me what, and this is something we've talked about on the program before, what is the magnetic field near a magnetar?
Josh isn't
And
excited about
3,
this trivia.
how big does the magnetic field have to be if you want to levitate a frog?
If you want to levitate a frog,
I want to levitate a frog.
Okay, I have so many questions. Do the frogs follow a magnet?
No, this is just a normal frog. Living frog.
Is this a
but
new
I mean,
experiment we can do?
This is a real
is the
experiment
frog
that
sitting
they've
on a
done.
magnet, or it's just the frog levitates in the magnetic field because of the stuff in the frog?
Yes, that's correct.
The latter.
Yes.
Just because the stuff
Probably
in the
like
frog.
faulty. Does it have magnetics to frogs?
My trivia
I'm gonna learn a lot more about frogs during this
had
trivia.
nothing to do with anything, but was also completely not stressful. But I'll save that for another
This is
day.
your trivia.
Yeah.
It's never stressful for you.
I know. So it's
It would not have been stressful for you guys either.
Oh.
All right.
But now you'll never know.
Well, we will next time.
So Da Vinci Plus
Oh, yeah.
and
Switch back to that.
Veritas are the 2 missions selected by NASA, and you're saying they're complementary because one's an orbiter,
One's an orbiter.
one's a probe,
One's a probe with a spacecraft that orbits.
also with an orbiter.
Yeah.
So the
One-
probe is going to land?
I mean, it'll hit
It
the surface.
will hit the surface.
Oh.
But it's an
Uncontrolled manner?
atmospheric probe.
Okay.
So it's intended, so this is Da Vinci Plus and Da Vinci
The-
Plus
the
is an
plus
What
is
is
acronym.
it? What
the
is it?
plus is the orbiter.
What is
part.
the acronym?
That's a great question, and the answer to that is Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. Gases is not included in the acronym.
Da Vinci.
Da Vinci.
Da Vinci Plus. Da Vinci Plus.
And they just add the plus because they don't want it to just be Da Vinci.
I think they added the plus because there was a previous iteration of this proposal some cycles ago in the discovery round without the
It
orbiter.
was just the probe.
Yeah, and then they revamped it and
If it
added
was-
the orbiter.
Yeah, I mean, it's good to have an orbiter because you can do context stuff first, then you can drop the probe, and the probe can then send the stuff to the orbiter, so you don't have to worry about it sending it all the way back to Earth
Right.
or to whatever other satellite.
Right.
And then Veritas, which is Venus Emissivity Radioscience INSAR, which we'll explain what that is, topography and spectroscopy. Veritas. There's some acronyms.
Yeah.
But they're fun mission names. So yeah, so Da Vinci Plus will have a probe that goes down into the atmosphere.
I like that.
And it will, probably won't take very long to go through the atmosphere.
It's thick, but these things are usually an hour or
Descent.
2 tops.
Yeah,
So does that look like a big parachute or something? So it's
it does
like
have a big
slowly?
parachute. It says
Yeah.
about a 63-minute descent, so yeah.
Oh.
Yeah.
And it has a mass spectrometer. So this is a little thing that can like sniff gases, sucks them in and sniff them, and get the composition with the noble and trace gases. A tunable laser spectrometer, so there will be a nice little laser spectrometer that can also look for certain gases and isotopes. And then there are some other like surface sensors that are going to look like as it's going down, it'll measure like its distance to the surface to look at like imaging and descent
Yeah.
distances.
I mean, I'm very excited about both of these missions, and the probe is obviously a necessary thing you got to do for Venus studies. But I'm always,
You want
you just
something to stay there.
know it's like this
One
one
spot.
line through
Yeah, it's the same problem we have with like the what was the Galileo?
the Galileo probe.
probe?
I was
It
going to
didn't
say,
have a
we
different
did
name.
that for Jupiter,
Yeah.
right?
Yeah, for Jupiter, we have like no data about the interior of Jupiter, and we're like, well, it's water depleted, but it's probably just like that spot
was
water
dry.
depleted.
Yeah, didn't it end up being, I don't remember as very well, didn't it end up being like an atypical region that it went down
Yes.
through,
Yeah.
and that's,
Yeah.
Yeah,
yeah.
So yeah,
and like Huygens, when it went into Titan, got a lot of great data.
Yeah.
But it's one spot.
The advantage with Venus is the atmosphere is, I think, a little bit more
More,
homogeneous
yeah.
than Jupiter.
Although some of the Japanese spacecraft is showing that there's interesting like cloud.
Oh, yeah.
I mean, there's clouds, so there's cloud formation, and they're seeing interesting structures and stuff like that.
Yeah.
And then there's an orbiter instrument that's going to basically have a camera in the IR to look at the
Infrared.
infrared to look at the surface.
And Da Vinci Plus is radar mapping, right? It's not Da Vinci Plus, Veritas.
Veritas.
is-
Yes. Yeah. So that was the INSAR was part of the acronym
Mhm.
is because one of the instruments is a synthetic aperture radar.
Oh, great,
which
it's
is
an acronym within an
It's
acronym. Is
an
that- Can you do
acronym
that?
with an acronym.
Ooh, that's
And it's
next
an
level.
interferometric synthetic aperture radar.
Okay,
Yeah.
so the I
I mean,
in
you could spell
Veritas,
out the whole thing and have, but it doesn't fit on one line.
Veritas.
And so synthetic aperture radar is where you're shooting radar basically down to the surface, and you can understand a lot about the surface topography, the structure, but also a little bit about the, I don't know, structure and things like that. We used SAR on like Titan.
Yeah, so the
Also an art.
the Magellan mission, which is the last U.S. mission to
Mm-hmm.
Venus, was launched in the 80s, was a radar mapper,
Yeah.
basically.
So this will be high resolution and it'll do interferometric stuff, so it'll give us more like a 3D understanding of some of the shapes and things like that. And then it also has a Venus emissivity mapper, which has, it's like actual wavelengths that can see through the clouds to look at some of the heat and the emissivity of the surface.
Oh, okay. And that's a huge, I mean, one of the big questions for Venus is how, like, is it geologically active
Mhm.
at the present time, or how recently was it geologically active? There's been periodically these suggestions that maybe like volcanoes are still
Sort of,
doing something
Yeah.
on Venus, like even, these days.
yeah.
But
geologically
it's sort of,
recently, at least.
it's sort of controversial about whether it's like that maybe has happened within the last 50 years, but it's not even known, like, okay, it wasn't 50 years ago, but maybe it was 50,000 years ago. Oh no, it was 50 million years ago, or oh no, it was 500 million years ago. I mean, there's just a lot of uncertainty about how, and so that those heat measurements are key to like seeing what the flow of energy is out of the surface. We know the surface is hot from trapping solar input, but what's coming out
Yeah.
is a key question.
And a
So
little
these
bit
are
about
good.
the competition.
Yeah, they're really cool
Competition.
questions because it's very similar in size to Earth. I mean, it's like our sister planet. It's very
Yeah.
similar, but yet it has got some significant differences, like no plate tectonics and stuff.
Right.
It's
Yeah.
interesting to know why it's so different, and
Right.
these are excellent scientific questions. I'm glad we're going.
Yeah.
Part of the argument.
I want a rover, though.
You want a rover on Venus?
Yeah, I want to rover on Venus.
I think you gotta. We
It's
gotta
2020. Wait, what's it?
It is 2020. 2021?
That'd be
Is that the year you're going?
2021.
That is what year it is.
For a second, I really thought it was 2022. I was
Oh.
confused.
I want a cloud city on Venus. I don't want a
Yeah.
rover.
You
I'll
don't
have to
want
go for the
Or at
cloud
least a
city.
nice dirigible. to start.
Oh,
The cloud city could be mobile,
Okay.
and then we can call it. You can call it a dirigible. I'll call it cloud city.
You think Bigelow's working on that?
No.
No.
All right. Let's hear about. I thought all my life I understood what caused aurora, admittedly in a very sort of simplistic way.
Yeah.
Then there's this headline that says, "Oh, we finally figured out what caused aurora," and I was like, "Uh-oh."
I saw the headline too, and I was like, "Holy crap!" I thought is it along exactly the same lines as you. I thought we knew. I thought we understood aurora for
Right.
decades and decades. I didn't think it was a mystery. And I actually still don't think it's a mystery. I think that was just a
It's a
one of
little,
these-
it's a little
An
extra,
attention-grabbing headline.
little extra detail of how it's
Right.
working is confirmed.
right, right.
And one of
right.
the sentences in the article is, "We've understood for decades how we think it's done. This research,
This
just
experiment
confirms
confirms it
It's an actual
experimentally.
experiment, yeah.
Right.
It helps confirm it.
Yeah, and
So how have we been explaining it all these years in our
And we'll
simple-minded
probably keep
way?
explaining it that way.
And we
I will
probably will.
absolutely continue. Yeah, I mean, well, it's basically right. I mean,
Most
It
of the
is.
time, we don't go deep into plasma physics when
That's
we
right.
explain
No.
aurora.
I haven't really
it's
talked
already
about
complicated enough for people who don't know things about. I mean, like, so basically, it's just the sun is always throwing off charged particles, electrons and protons and things like that, and
The solar wind.
solar wind. Those charged particles get deflected and collected kind of by the magnetic field of Earth, and those high energy charged particles get shunted usually towards Earth's poles, magnetic
Spiral in
poles.
around
Yeah,
the
they
field
kind of
lines.
get caught around the magnetic field lines and spiral in towards the poles, and then they interact in the upper atmosphere with molecules in our atmosphere.
Yeah.
They knock electrons off of those things, and when the electrons and the atoms recombine, that produces
Light of different colors.
different colors depending on which particular molecule
Molecule it's hitting.
And that's
Which
why
is-
we mostly see aurora at the poles, is because it's where the particles have high enough energy to come in along these field lines, and sometimes that auroral oval sort of extends further south. You get to see it, but I've still never seen it.
I saw
It's not getting to Florida anytime
I
soon.
saw it once
No.
from an airplane,
It was supposed to get into Colorado one time when I was there, but it was cold.
Alaska's a good place to see it in the winter.
Iceland.
Yeah, that's the trouble. All the places that are great to see it, I mean,
You have to go there in the
you have to go
winter.
there in the winter because it's daylight all
All the time in
during
the summer, right?
So you got to go in the winter. But who's going to
Who
Alaska
wants to
in
go
the
above
winter?
the Arctic Circle in the winter,
Yeah.
right? Yeah.
But I would just to see
So,
those.
well, the experiment they did,
Yeah, this is cool because it's like an actual like laboratory experiment to kind of show how some of this physics works, right? And I'll admit to not really understanding what's going on, but there's this. Basically, these electrons and so forth get accelerated by these weird electromagnetic waves.
Alphane
Alphane
waves, named
Yeah.
after
Hans
Alphane.
Alphane.
who was a physicist. He died recently, but he won the Nobel Prize, I think, in 1970 or so.
And
Did he die recently? I would have thought he had died a long.
Maybe he died a long time ago. I don't know.
I don't think it's
I mean,
germane to the conversation.
I think he died in the 90s, 1995
Okay.
or something like
That's
that.
pretty recent.
That's I call it recent.
Yep.
But yeah, he did win the Nobel Prize. He's a super weird guy, right? He was obviously a great genius. He had a huge number of contributions to plasma physics and all these kind of physics.
Can't
I
get
mean,
away from him.
you
with
must,
the
yeah,
plasmas
you
and stuff.
Addie
Yeah.
must be a lover of this guy, but
Well, I don't know.
he kind of not lover.
That's not the name.
He's
of the
no
job
Iron
he's
Man.
in.
An Alphane lover.
But he kind of went crazy in his, I don't know, crazy is the right thing. In his elder years,
Uh-oh.
he hated the Big Bang model, and he came up with all these alternate
Oh, weird.
alternate theories trying to explain away the cosmic microwave background, that kind of stuff with just these weird electromagnetic phenomena. Anyway, he was entirely wrong and crazy in the cosmological stuff, but obviously was great in the other stuff. But anyway, I don't pretend to understand what an Alphane wave exactly is and how this is, but it's some way of really accelerating these electrons up to the kinds of energies that you need to penetrate deep down into the atmosphere to produce the aurora or some facets of the aurora.
Yeah, you need to, so you want your electrons to have enough energy so when they smack into your atmospheric molecules that they excite the electrons or the energy states of those molecules and atoms to the right levels so that when they de-excite, they emit beautifully green or purplish or blue photons for us to marvel at. And what I think what was particularly cool about this experiment is it was big.
Yeah.
Like, the aurora are a large-scale planetary phenomenon,
Right.
right? So it's hard to let's really reproduce what goes on in the aurora in a lab.
Because a lot of there are other plasma experiments that have Alphane waves in
Right.
a smaller vacuum chamber in a laboratory setting.
But getting the particular sort of
Getting
parameters that we see in the aurora is hard to do.
Yeah.
And so this was a big plasma chamber that
20
was
meters long.
20 meters long.
Yeah,
That's
it's a big
big.
lab.
That
Yeah.
is a big.
You gotta have big labs to make big
Tank.
accelerations.
Yeah,
is what I-
as department chair, getting a lab that's 20 meters.
yeah.
Let alone a chamber.
Yeah.
I mean,
But how do you get that space? Come on.
If I ask for that, you gonna give it to me?
No,
no,
you don't do that stuff.
I'm
To be
not.
fair.
But what if I? Well,
I don't have that stuff,
anyway.
No one has.
so I'm not going to give it to anybody. Who asks whether they could make good use of it or not. So they did this really large scale experiment. Put a plasma in there, and then they excite a plasma wave in it.
The large plasma device.
Yes, very clever. And they excite waves in the plasma by pulsing an electromagnetic field, and that causes waves to propagate down. Then they inject electrons into that plasma and then sense those electrons. So a lot of times it's like you can think of the experiment. It's not so hard to set it up, but then figuring out what happened can be as tricky
Right.
as the experiment itself, like getting the measurement. Like I always think about this with the Bose-Einstein condensate. It's like, okay, we got to take these atoms, we got to cool them down to like a millionth of a Kelvin or whatever, and then it'll form a Bose-Einstein condensate. And it's like, yeah, but you have to have to
How do
show
you
that
know
that
you had that?
you have
Yeah.
to show that actually happened
Yeah.
some way and catch.
Right.
So it's all that kind of experimental stuff
Right.
is
So what
very challenging.
What they weren't doing, I mean, they weren't like producing visible aurora in their little plasma chamber, but they were producing
fast
these super high energy
electrons.
electrons
Right.
that you would need.
Yeah, they likened
Super
it
cool.
to sort of like surfing on like a surfer surfing on a wave. which-
Right.
Getting accelerated.
Yeah.
Yeah, and I mean, and we talk about aurora here on Earth, but we see aurora on other planets, and these
Right.
alpha vane waves and accelerated electrons exist in other astrophysical environments as well. So it's not just an aurora.
Jupiter and Saturn have some pretty impressive aurora.
Yeah.
Right.
Yeah, alpha vane waves pop up everywhere in plasma physics.
Yes, and
And
interstellar,
astrophysics.
which
Yeah.
brings us back to your trivia.
Ooh, magnets.
Ooh, magnets.
So to make
How do they
aurora,
work?
all you need is a few Gauss worth of a magnetic field. But what kind of magnetic fields do we have in other places?
I feel like I should know this, but I haven't taught physics too. In
I'm
several
gonna
years.
be orders of magnitude off
It's
on
so
every
easy.
single
All
one of
you
my
have to do-
answers.
It's
Right.
so easy to be orders of magnitude
Oh, yeah.
off with magnetic.
And all I'm
fields.
asking for here really is orders of magnitude.
That's all
So
you're gonna get.
yeah, for sure. That's all I really know.
All you're
All right.
asking for is the
So
impossible.
let's start with the small one, interstellar.
What's the
magnetic
what's the
fields.
magnitude?
What's the order
interstellar
of magnitude
field?
of the magnetic field strength in interstellar space in the Milky Way galaxy?
I should really know this.
And
How
you
many
want this
Tesla?
in
I
Tesla?
want this in
Tesla.
Tesla.
Well,
You can give it to me in Gauss if you want. We'll have to do the conversion.
I'll say 10 to the minus 6 Tesla.
Okay. A millionth of a Tesla.
10 to the minus 8 Tesla.
10 to the minus 8, 100 millionth of a Tesla. It's actually about 10 to the minus 10 Tesla. Not bad.
Not bad.
I was
Not
off
bad.
by 4 orders of magnitude.
Four
I
orders
told
of
you
magnitude.
I was going to be off by orders
You're
of
only off by
magnitude.
4.
Yeah.
I
But
was
that's still
psyched
enough.
out-
It turned.
I was psyched out by you asking for the answer in units of Tesla instead of Gauss,
Yeah.
Weird.
which
That's
is
why we always refer
bigger.
to Tesla or the magnetic fields as in Gauss and the small
Right.
astronomical
Because they're
terms.
very small. But
Yeah.
sometimes they get very big.
My answer was correct if it was in Gauss, actually. It was exactly
Nice.
right.
Aha, that's what he was thinking.
That's what I was thinking.
What else did I ask? Oh, what about the very big ones, which we've actually talked about before? I've given this
Magnetars?
answer before. Yeah, magnetars, which are these neutron stars with very high
Magnetic field at
fields
the surface of a magnetar?
Yeah.
In Tesla?
in Tesla.
10.
10 to the 10?
No, 10 Tesla.
10
to the
Tesla.
1. 10 to the 1.
10
I'm
to
going
the
to say 10 to the 4.
10 to the 4? 10 to the 11.
No.
You should have said, you went with 10 to
You're
the 10.
close.
That's what
I
you
said
meant.
10 to the 10,
You
right?
said 10 to the
You were
10.
only off by 10 to the 10.
You're only off by 1.
No
You're
problem. That's a pretty wide range of orders of
We could
magnitude
do-
of magnetic fields that we're interested in nature, right?
We could
10
do
to
a
the
powers
minus
of 10
11 to
video.
10 to the positive 10.
We could do a powers of 10 video with magnetic fields.
Yes, it's pretty
It's
awesome.
hard to visualize.
That
That's
would
pretty
be
great.
hard.
What about levitating a frog? What do you think we need for that?
Yes, 10.
10?
10.
10.
I'm going with 10.
All right, that's a good answer. I'm going to give you guys credit for that.
Yay.
It's about 16 Tesla. Is what-
Oh.
No, we're definitely.
We're definitely-
You're right.
You're not giving
Yeah,
it to
we
us.
were
That's
correct.
correct.
That's correct.
If you're asking
Orders
for
of
order of
magnitude. That's
magnitude,
correct. That's
that's-
100% correct.
There is no better answer than 10.
Why? Can you explain this a little bit more?
Yeah,
Not
how does
really.
the frog get levitated?
Oh, Jim, what?
Frogs.
That's all anybody listening to this podcast who's
Yes, no
suffered through
doubt.
all of this ridiculous crap cares about. Is
Yeah.
how the hell do
How do you-
you levitate a frog?
Yeah, well, they're very weakly magnetic, and
Why?
if you have a powerful enough magnetic field, you levitate them.
Why are frogs weakly magnetic?
Well, I think
Atoms
the
and
idea
things.
here is the atoms and everything
Because.
Huh?
Because.
are
Yes.
magnets. They're
Yeah.
little tiny magnets with little tiny magnetic dipole moments.
Right.
And if you put a strong enough magnetic field around them, then
They
those all line
Going
up the same way.
Right.
And so the frog itself then becomes
A
a
magnet.
magnet, and then and if it's South Pole and you're North Pole there, then you can levitate this thing. But it takes a ridiculous. 16 doesn't sound like a very big number, but that's of course because, like we said, the Tesla, even though it's
Okay.
the natural.
16 is like the largest. I mean, that's sort of the order of the largest laboratory magnetic fields that are produced.
It's close to
for
that.
very, very short periods of time in big labs here on Earth.
We do a little bit better than that nowadays, but yeah,
But not hugely better, like what, 100?
right. So the largest permanent magnets that we have are about 5 Tesla. The largest
Sort of burst.
the largest magnets that we make that are non-destructive are about 100 Tesla.
Okay.
And then we can do the largest one indoors that we've ever done that is destructive is 1200
Where was
Tesla
Oh,
in
wow.
Japan. They did
Yeah.
that.
Was
They
it for,
do
like, an
that by
accelerator?
what's that? I mean,
They-
the trouble is
they
if you
dump-
to make that you
they-
need a ridiculous current which just melts everything
Right.
away.
Yeah.
So-
Your wire is like a foot across.
I need
Yeah.
a little,
Because
I
you're
need like a little
pumping so much current through that
Yeah.
Oh,
wire.
ridiculous, and it just
Yeah.
blows it up basically
Right.
when that does that. So you get
So-
it's like for for not nanoseconds, but like
Sure.
millionths of a second,
Yeah.
a few tens of millions of a seconds, they make
Was it for an
this.
accelerator thing, or was it?
No, it was just
for
to
the
do it,
elements.
Just to
right?
do it?
Just to do
It's-
it. We do need really powerful magnets for these accelerators. So like
Yeah.
for the LHC, the magnets and their
You
electromagnets,
sometimes
of course.
can tell in the video in the pictures. There's like big coils of.
Yeah,
magnets
I mean
like
that's one of the really hardest parts of a thing like that. I mean, you're taking these protons but you're whipping them around a
You're
big
trying to make
circle,
them turn.
but they're going nearly the speed of light, and so to turn them, you need a ridiculously powerful magnet of something like
Right.
8 Tesla.
Yeah.
Okay.
I mean, those are
Nice.
crazy magnets.
Wow.
Which, by the way,
Crazy
is
magnets.
not
Do
so
not
far
go
away
in there
from.
with your credit card or your iPhone.
No. No. The most powerful magnets you'll come across in your everyday life, hopefully you won't come across too often, is in an MRI machine, right? So if you,
Right.
this is for imaging your interior
What's the
without.
strength of those?
It's similar. It's a few Tesla.
Really?
Yeah.
So if I had a frog with me in the MRI, it
Would
would
it
float?
levitate?
Not quite. I mean,
But it
the
would-
difference between 6 Tesla and 16 Tesla is pretty significant. I think a typical
10.
MRI machine is 2 or 3 Tesla,
Okay.
which isn't enough to.
It's an order of magnitude difference.
So let me ask you this, if you take so you have, let's say you have a permanent 16 Tesla, and I take my frog and I drop it, does the frog levitate or does it go down, just get slammed down? Because if I turn my magnet upside down and they're
Yeah.
different.
You're right. I don't know. I've never tried to. I feel like it would slap down because
That's what I want to
Yeah.
think would
usually if you
happen.
have 2 magnets and you're trying to
Right.
Yeah.
It's gonna
it
flip
wants
over.
to flip over and do
Right.
that. So you have to have like extra magnets on the side to kind of stabilize the system. I have no idea. I didn't. There's video of
Is
this
there
frog
video? Okay.
being.
Oh, really?
Maybe we'll put a link to it if
Okay.
we can find that easily.
All right,
I mean, yeah. Okay.
yeah,
And it lived. It's fine. No worries.
okay.
I mean, you're okay when you get.
Yeah.
That's the great thing about MRIs is like. The other way to see inside you is like CT scans and stuff. Those
It's
use
radiation.
huge amounts of radiation, and you don't
Yeah.
want to get too many of those in your lifetime. But
Yeah.
MRIs, dime a dozen. I
Yeah.
mean, they're not a dime a dozen. They're ridiculously expensive.
They're expensive, but yeah,
They don't hurt
Pretty
you.
cool technology.
it's totally fine if your atoms get their magnetic.
Yeah, they'll go back to
There's
random
there's
soon
flipping
enough.
things.
Yeah.
Hold it. That's pretty
Yeah.
cool.
Well, it may have felt like the time since we last sent a mission to Venus. It was just another episode of Walkabout the Galaxy. Write us a review and TV guide.
Oh,
That still exists.
we were talking about that recently.
Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you can see most of our episodes, some of our bloopers, and all our music videos. And we got some good bloopers at the start of this episode. Just saying. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Rusick. Thanks to our listeners in Ohio, in the USA, and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astroport, signing off until the next episode of Walkabout the Galaxy.
4.
Oh, yeah.
You get to like show
Like
on
some
the
muscly guy.
And Chris
and Chris
Hemsworth.
Yeah. But also you get to like go maybe travel to other worlds. He's got some-
That was
he's
a pretty good.
Pretty good.
I think that was a pretty good pick.
He's a sexy guy.
Yeah.